Okay, so we're looking now at the graphs of trig functions, and we're just going to start. I'm going to start with the basic curve y equals sine x. Now, obviously, all these other things can apply to cos x and to tan x, but it's highly likely that you'll only ever get asked about sine x or cos x because they're a bit easier to draw. So, when we make changes, we can change the amplitude, we can change the period, we can translate it sideways, backwards, left or right, or we can translate it up or down, or we could turn it upside down. So these are the changes we're looking at. Okay. So in the first one, I'm just going to, from Desmos, we've already drawn sine x before, and it's a very nice shape. It's a periodic function, and the amplitude is 1 because it goes, okay, change the pen. Okay, so the height from the middle to the top is 1, so we say the amplitude is 1. And the period, which is the time it starts at a particular spot and gets back to the same spot. So for instance, it's 0 and going up, 0 going up. So that length there is the period, and in radians it's 2 pi, or in degrees it's 360. Okay, so let's remember that the amplitude is the height of the curve measured from the middle. So here's the middle is where it sort of oscillates around, and so the height is 1, and the period is the angle or the time needed before the function repeats itself to the same spot. Okay, so the period, so it doesn't matter, like even if it was there to there, that length of time is 360 degrees or 2 pi. Okay, so on Desmos, I want you to insert some sliders. So get your graph up. I want you to draw y equals a sine bx, and I want you to change a and I want you to change b and see what happens. Okay, so spend a few minutes doing that, and when you're ready, come back and we'll have a look at what I was saying about a and b. Okay, so you should notice that the value of a affects the amplitude, so it makes it go bigger, and the period, while you might not have picked it up, it's a division. So the period changes by dividing 2 pi by b, or 360 by b. So what's happening, let's have a look at the next one. So copy that, and when you're ready, come across. So for instance, if I've got 3 sine 2x, okay, and we're going from 0 to 360, and this question is a sketch question actually. So the amplitude is 3, and the period is 2 pi divided by 2. Now I've got 360, so let's make it 360 divided by 2. So the length of a period is 180 degrees. Okay, so it's just a straightforward graph. There's no real things to worry about. So it's 3 to minus 3, and I'm going. Okay, so I've got 180. So so that's 180 because I'm going to go start at 0, go up to 3, back to 0, down to minus 3, and then back to 0. So I'll change colors, and so my curve looks like this, bit bumpy. So that's one cycle to 180, but the curve has to go to 360, so I just need to do another lap. So down, 2, 3, 4, and just keep it going. So that's from 0 to 360, so it cycles through twice. 180 is a cycle, but I've got to go to 360, so I need 2 cycles of the period. Okay, and you try to draw it as neatly as you can with curves. Okay, so to move the curve sideways, and when I say sideways, I'm meaning left or right. What we have is brackets. Okay, so for instance, now I've defined the bracket with a minus sign. So if the number that you put in is a positive, means that you have a negative in here. So if theta is positive, you have a negative, and the curve moves to the right. Whatever that number is, that's the number to get. Now, just note, at the moment, I've got a 1x, because if I have numbers there, that changes up, which I'm going to show you a bit later. So if theta is negative, which means I'm going to have a positive in the bracket, then the curve goes the other way. So basically, if there's a negative in the bracket, the curve is being shifted to the right, and if there's a positive in the bracket, the curve is being pushed to the left. And you can put that on Desmos and see what's happening. You could put a slider. You could call that a letter. If you wanted to put a slider in Desmos and see that what I'm talking about is right. So if you put x minus b and then change b around, you'll see that the curve goes right and left the opposite way. Okay. So if I want to move up and down, then I just have to put a number at the back. Okay. So if I want the curve to go up or down along the y-axis, up or down, then it's just this number at the back. So for instance, if I've got a positive number like +3, then the curve is going up 3. Okay, so this one does follow the number, and if b is a negative, such as -1, then everything goes down -1. So what's happening for the first one is it's taking the sine x values, and for every sine x value it's adding 3, or for here it's taking all the 3 sine 2x values and then just subtracting 1. So the back number actually just goes up and down whichever it has, but the brackets you do the opposites. Okay, so let's see if we've got an example. Oh, no, we're going to do inverting. So to flip the curve upside down, we just have to change the sign, change the ratio to a negative. So for instance, if I've got minus sine x, instead of the curve going up and down like a normal curve, like the normal sine x, instead of going up, I go down. But please note that even if the curve goes down to start with, the amplitude is still 1. The maximum height is 1. So the amplitude doesn't change. Like the coefficient is -1, but the amplitude is not -1. The amplitude is +1. You just take the absolute value, the positive value. Okay. Let's see what happens on the next slide. Okay, so what I'm doing is I'm putting all these things together. Now I've got inside the bracket, I've got bx plus c, but before you can do anything, you've got to factorize. Okay, so I take the b out, so b times x is still bx, and b times c over b equals c. So the c is still there, but I've turned it into a fraction because I've taken the b out. So the amplitude is the number out the front. Okay, so the amplitude is out the front. The period is 360 over b, or 2 pi over b. Okay, the sideways move, now by whatever reason I put a plus there, so that's the sideways move, and because it's a positive in the bracket, it's going to go c on b backwards. If I had a minus in the bracket, it'd be c on b forwards. And the up or down is just this last number. Okay, so what we're going to do is we're going to do a couple of examples with quite straightforward, complicated, and the complicated one. Okay, so copy down when you're ready, come across. Okay, so this first one isn't complicated too much because I don't have a bracket. There's no bracket here, it's just plain old 3x. And I'm just going to do one period. So what you need to do is like put a little legend on the side. So the amplitude is straightforward, it's 2. The period. Now I didn't define, so let's stay in degree mode. Let's stay in degrees rather than radians. So it's going to be 360 over 3, so the period is 120. So that number there was 120, that's going to be 60, that's going to be half of that 30, and then add those together, that's 90. And it's actually called a translation, but if you just say up or down, that's all right, and it's going to go 1 up. Okay, so it's a translation, call it up or down. Now what I'm going to do is and again, I'm not saying you have to do it this way, but this is what I would recommend. So what I'm going to do is I'm just going to draw this 2 sine 3x curve first in very light pen, like you might do it in light pencil, and then whatever we're going to do that, we're going to shove it up 1 point. So sine starts at 0, we're going to go up to 2, and then down to 0, then down to -2, then back to 0. So this, if you do this in light pencil, I'm going to do it in a dotted line. So this curve is not the right answer, but I'm going to use it. So that curve is y equals 2 sine 3x. And then I'm going to change colour. I'll change to green, I think. So what we're going to do is this value here is going to go up 1. That value there is going to go up 1. That value there is going to go up 1. So now we've got like an imaginary dotted line happening where the x-axis used to be. So this line here at -2 goes up to -1. and 0 goes back up to 1. And then I'll just change colours again just to make it annoying for you. So here's the line. It's going to go up to 3. Okay. Oh, I lost this point here. So that's, oh, there it is there. So down to 0, then down to -1, and then back up. Okay. So that graph there is y equals 2 sine 3x plus 1. So you can see that I've done one cycle, and again, if you draw it on Desmos, 2 sine 3x plus 1, it sort of, instead of starting at 0, it starts at 1, and then obviously it does keep going the other way, blah blah blah, but you don't need to worry about more than one cycle. So have a copy of that, and let's have a look at the next one. Got a couple, I've only got one slide to go. Okay, so drawing the most complicated one that you might have to do under exam conditions. So first thing we do is, because this is not factorised, I need to factorise it. So take 2 out, and then pi on 2 becomes pi on 4, because when you double pi on 4 you get back to pi on 2. So the question hasn't changed, it's just been factorised. So the amplitude is the 2 from there, the period. Now I didn't say what mode, so let's stay in degrees, make it easier. So stay in degrees. So the period is going to be 180 degrees, 360 over 2. The sideways move, sideways, and that's actually, I'll use the proper, that's called a phase shift. Phase shift. We've got a minus, so the phase shift is pi on 4, and it's going to go to the right. So phase shift is left and right, and the up and down, so up and down, which I called a translation in the last lesson, in the last slide, sorry, is going to be 1 down. Okay, so it's -1, so I'm going to shove it down 1. So what I'm going to do is I'm going to start off with, first of all I'm going to start off with 2 sine 2x. That's going to be the basic curve, 2 sine 2x, and then I'm going to go sideways, pi on 4, and then I'm going to go down 1. Okay, so we're starting off with the basic curve. So the basic curve is that 2 sine 2x, and then it's going to go sideways, pi on 4, and then it's going to go down 1. So it's going to be like 3 graphs, not 4. Okay, so we're doing on sine. So sine starts at 0. The amplitude is 2. Now, so hang on. So the period is 180. 1, 2, 3, 4. So that's 180. So that's 90. Now, actually, look, I made a mistake there. We can't be in degrees because that's in radians, so we need to turn that into radians. So sorry about that. So that's going to be pi. All right. Yeah, so if it's in radians in the bracket, it has to be radians in the question. So that I should have picked that up earlier. Okay, so 1, 2, 3, 4. So that's pi. Half of that is pi on 2. Half of that is pi on 4. Add those two together, you get 3 pi on 4. Okay, so the basic graph of 2 sine 2x starts at 0, goes to 2, back to 0, down to -2, and then back to pi. So that's the basic 2 sine x, 2 sine 2x, sorry. Okay, so the important points are the tops and zeros, the bottoms, and back to zeros. So what I'm going to do now is just try to, if you can follow me, this first point here is going to go forward to pi on 4, and then we're going to go down 1. So basically that point there has moved to that point there, so it's going down that way. Okay, so that's the first point. So this point here is going to go forward pi on 4 to pi on 2, and then down to there. This point here is going to go forward and down. That point there is going to go forward and down. Okay, and that point is going to go forward and down. So I'll just, a lot of colours, but anyway. So, change to a good colour. I'll change to that funny blue. No, don't like that one. I'm going to change to that one. So, That's the first point. Okay, so that's my second point. Okay, that's my next point. That's my next point. And that's my next point. So joining them up. Okay, so that's a cycle, but it's sort of in midair, so I'm going to go back. Okay, so using the pattern, so it's going to come down. There. Okay, because that point there is going to be equivalent to that point there. So really my cycle could go from there to there. And normally you have to backfill. So normally the thing will say, 0 to 0 less than x less than equal to some number, whatever. So it means we've just got to backfill this part of the curve here. We've got to backfill it in. Okay, just use the shape. Okay, and I think that's the last one. So hopefully you enjoyed that explanation of graphing trig functions.